Okay, so hi there everyone. We're now on our next video about the laws of exponents. This is actually the second video now, and we will start by an example. Okay, so try to consider now the operation division. So take the expression, for example, a raised to 7 divided by a raised to 5. Or it can be written as actually as a raised to 7 over a raised to 5. Anyways, a fraction bar can be thought of as division, right? So again, by definition, let's try to recall the definition. Let's have a recall. A raised to n is equal to a times a times a lot of a's, and this is done n times. Okay, so this is our general definition of exponents or exponentiation. So if we're going to apply this here, we can see that a raised to 7 can be written as a 7 times. A times a times a times a times a times a times a. Okay, so this is 7 times 1, 2, 3, 4, 5, 6, 7. And we're going to write also in the denominator a 5 times. A times a times a times a times a. Okay. Now, remember our cancellation method, okay, in dealing with division or dealing with division of exponents. We could actually divide terms here. So for example, we can divide things like this there, since they are factors already, and we can divide. We can cancel out. So what is left here? This is actually equal to, as you can see, we are left with a times a all over 1 in the denominator. So it can be simply written as a times a, and a times a can be written furthermore as a squared. A squared. So that in such a way we can see that in short, a raised to 7, a raised to 7 divided by a raised to 5 is equal to a raised to 2. So observe that the 5 a's in the divisor were cancelled out with the same number of a's in the dividend. Being cancelled out actually means being reduced to the lowest terms. Hence, the remaining factors, there are 2 a's, can be obtained by subtracting the numbers of factors in the dividend, 7, and the number of factors in the divisor, 5. So a raised to 7 divided by a raised to 5 is equal to a squared, or if you want, we can further write this down, a raised to 7 minus 5, which is equal to a squared, or a raised to 2. Okay? Now, this result gives us our second law of exponents in our book. So the second law of exponents is actually called the quotient of powers. In a while, the quotient of powers. This is our second law. Okay, so what does this second law give us? So the quotient of powers, to divide terms, oops, sorry, let's make it red. To divide terms with the same base, again, same base, subtract the exponent of the denominator from the exponent of the numerator. Okay, subtract the exponent of the denominator from the exponent of the numerator to get the exponent of the quotient. In symbols, we write it as this: a raised to m divided by a raised to n. If you want, you can write it in the conventional manner: a raised to m divided by a raised to n. It's just the same thing. Okay, a raised to m divided by a raised to n is equal to a raised to m minus n for all m and n which are positive integers. Okay, so m and n are positive integers. Okay, so to give us more examples of this, let's have a very short example such as this. Let's have something like example 1. Oops, sorry. First example. Say we have a cubed b to the fourth c raised to 5 all over a cubed b squared b squared c. Now what will we do? We will subtract by the same base. So we can see here that this is equal to a raised to 3 minus 3, b raised to 4 minus 2, c raised to 5 minus 1. Okay, so what's the answer here? A raised to 3 minus 3 is going to give us a raised to 0. Oops. B raised to 4 minus 2 is gonna give us a square. C raised to 5 minus 1 is gonna give us 4. And this is our answer, only that we can simplify a raised to 0. We're going to talk about that in the future, but any number raised to 0 except 0 is going to be 1. So since this is 1, we can cancel this out. That leaves us to our answer squared, b squared c raised to 4. So this is our answer for number 1. Okay? B squared c raised to 4. Okay? Now, for our last example, for this one, let us have this. Okay, let me write this down. This is example 2. What we have is 10 a raised to 4 b raised to 7 divided by, oops, divided by minus 5 a raised to 9 b raised to 2. Okay, you can pause the video if you want to answer it. Go. Okay, so I hope you have the answer there already. So let's try to answer this. Let's start off and simplify the coefficients first. Not yet. So 10 divided by minus 5 is going to give us 2. But since they don't have the same signs, it's going to become minus 2. Okay, A is going to be 4 minus 9. So 4 minus 9. Again, remember, it's going to be numerator minus denominator. Okay, always. And B raised to 7 minus 2. Okay, and then what we'll have is minus 2, a raised to 4 minus 9. What is 4 minus 9? So it's going to be minus 5. And b raised to 7 minus 2. What's 7 minus 2? That's going to be, it's going to give us 5. Okay, and yeah, that's our last step actually. But um, we will talk about this in the next video. But take note, if we have a negative exponent, it's improper. Okay, it's not proper to just write it like this one because we cannot operate with negative exponents. Okay, we cannot trace something with a negative exponent. So we find ways to get rid of this negative sign in the exponent. So how do we do that? We transfer whatever term that is with a negative exponent in the denominator and then get rid of the negative sign. Okay, now what would be the answer? So meaning this a here is being raised to negative 5. So to get rid of the negative sign, we should put the a raised to 5 in the denominator in order for us to get rid of the negative sign. Okay, and what remains here is the numerator, so negative 2b raised to 5. The explanation of this will be talked about in the future video wherein we have a law for negative exponents. Likewise, in the previous example, we have a law for zero exponents. So that will be talked about in detail in the next video. Okay, so thank you very much for watching. I hope you have learned something here. And yeah, don't forget to like this video and subscribe to my channel for more math videos. Okay, so thank you very much and see you soon. Thank you.